Garen Phillips here, and today I'm going to be showing you how I created this. And this is a casting for a 671 supercharger made out of A356.2-T6 heat treat, and it was created from this. Not this, this. Here's how it's made. This video is brought to you by Diamond P Industries, an American manufacturing company making parts for Americans by Americans. Alright, so before we have a casting, we need to make a pattern and a core box. These will be used to make the mold, which will have metal poured into it, and that will make the casting. I know everything's moving really fast right now, but you're actually watching about 23 days of work, so it's all condensed down to about 10 minutes, so I know everything's hard to see, but what's going on right now is in the first section of the video, that is the machine cutting the pattern, and this will be mounted to a metal board you'll see in a minute. And the video on the right is the machines cutting the core boxes and loose pieces, which you'll see how those work in a little bit. And all this is possible, and these machines are able to do this because of a software called CAM, which is an abbreviation for computer-aided machining. And how that works is I can take the models of anything I design and send it through this software, and the software will automatically write the toolpath and tell the machines how they need to cut in order to cut complex shapes. And those shapes can be used to make molds, which will make castings. Even though everything's moving fast, you can probably see that they're being cut out of 3-inch blocks, and this material is actually not wood, it's called Renwood, it's plastic, and they're being cut out of sections instead of a solid block for accuracy reasons. This enables us to run a smaller end mill so we can get a lot finer cut, because the longer your end mill is, the more run out you'll have at the end of the cutter. And we try to keep at least 3 to 5 thousandths accuracy within our tooling. And now you can see on the left video the aluminum plate being machined. The pattern that was just cut will be mounted onto this. Right now it's cutting the pockets on the underside. And now we're mounting the pattern to the plate and remachining the rest of the pockets into the plastic. And the right video, you can see the machine cutting the loose pieces for the core boxes. And now that the pattern's done and mounted and ready, we're just doing some touch-up to it with filling in any holes or drill spots with tough fill. The wood blocks I'm messing with right now are actually going to be hand ground risers, and risers are used in a mold in order to help feed the metal of the casting, because as metal cools in a mold, the hot to cold spots will actually pull away from each other and create voids and weak spots in the metal. So risers let the metal feed from the outside of the casting into the casting so that the casting will cool before the risers do. And what I'm doing now is creating the gating system for the mold, and this is actually being made out of mahogany. But the gating system is used to control and channel the metal from the outside of the mold to the inside of the mold. The silver paint that's being put on the pattern is a special paint made for patterns as a release agent so that the sand doesn't stick when you make the molds. But now that the pattern's done, it's time to take it over to the foundry. And now that we have the pattern at the foundry, just have to do a bit of touch up to it to get it to fit right and work with our molding stations. The red blocks sticking out of the top of the mold are the risers that I spoke about earlier. But the metal box that the sand is being dumped into is called a flask. You have the top and the bottom, also called the cope and the drag. And you can see the aluminum plate in between both of them, which is the pattern. Now this is the core being placed in the mold that I spoke about earlier. I didn't put the video in of making the cores because this video is already too long. At the end of the video I'll have a link to the video that actually shows how the cores are made and how they work. Once the mold's done, it's picked up and put on a pallet, and the pallet's slid across the pouring deck. The metal box being put on the mold is called a jacket. It's used to help keep the hydraulic pressure in so that the metal doesn't burst out when it's poured into the mold. Now, this thing is called a Dee Gasser, and it's used to pump nitrogen into the metal to degas it to make it more pure. The metal that we'll be using is called A356, and it will actually be degassed to X-ray quality, and I'll speak more about that at the end of the video. Now, after every degas cycle, we have to take a small sample and set it inside of a vacuum chamber, and this vacuum chamber sucks out all the air. So it takes away the atmospheric pressure of 14.7 to down to 0 or even a negative. What this does is it creates low pressure on the outside of the metal, so as it cools, the gas that would be inside the metal has the ability to expand more than it would at atmospheric pressure. So it's really an exaggeration. So once it cools, we can take the sample and cut it in half and see any gas pockets that we normally wouldn't see if we didn't have a vacuum chamber. This is the first sample. Looks pretty good, but there's still a few gas bubbles in it, so we're going to degas it again.
Is that what we got now?
This is the second sample with almost no gas bubbles in it.
Look at this.
And grabbed another sample just to show you what a bad one looks like. And again, the samples are an exaggeration. If they were to cool at room temperature with atmospheric pressure, they wouldn't look like this. The vacuum makes them exaggerate their size. Now, I spoke earlier about risers and what they do. If you watch as the metal fills up to the very top of the risers, it'll actually bubble up out of the risers. But in a second you'll see the mold dumped out, and look at the risers and you'll see that they've actually been sucked down into the mold. The sand that we're making these molds out of is called green sand, and it's actually mixed with clay and water, and the smoke that you see coming off of the mold is actually steam of the water being evaporated.
Keep a while.
And again, with the risers here, you can see a better picture of how they have been sucked down into the mold, and they've become concave, where earlier they were bubbling up out of the mold before it had cooled. So that is how we made the 671 blower casting. Currently today is December 2nd, 2011. We have yet to get the fixtures made for CNCing. I'll take you out in a minute to our CNC shop to show you the machine that'll be ran on. We had them heat treated to a T6 heat treat, which is a 2-phase cycle heat treat. Now, I spoke earlier in the video about having these castings X-ray quality. Now, I don't have the X-rays or results back from the superchargers, but I do, however, have this, which is a casting that was made the same week for another company that is X-ray quality, and I can do a couple different things here with them to see variations, but basically all you have to look for in these is to make sure that there's no black dots anywhere in the casting, because that's a sign of porosity or air pockets or gas pockets inside the casting. And I also have the sheet results back from the lab of the composition and tensile and yield strength of the metal. These are the various elements and their percentage in the metal, and this is the yield strength of the metal, tensile strength and elongation. 42,000 tensile, 32,000 yield, and the date 11/23/11. So if you like seeing how things are made, you want to see the more in-depth processes behind manufacturing, subscribe, like my videos, share them, so I'm able to make more videos. But now I'll take you out to the shop and show you the CNC machine that'll be cutting these. This is our 6-pallet changeable Mazak 500 mill. Currently it is down, but this is the machine that'll be doing the entire machining process and boring. There you have the spindle. And the pallets come in through this door and then are locked in, and it's a 4th axis that spins this way, and the head can move in and out. Control panel, but currently the machine is down. We had to send out the control unit for the tool changer, I believe. Send it out today. Hopefully it'll be in within a week or 2. But as soon as it is, we can get to work on setting up and making the fixtures and machining the casting.